Okay, so we have discussed up to question number 14, and in question number 14 till question number 14 we have discussed the concept of conversion of one solid into another solid, or conversion of one solid figure into another solid figure, and we have seen ample number of examples based on this concept, and this concept has only one mathematical representation, and that is the volume before conversion is equal to the volume after conversion. Okay, so now let us move further and let us discuss the next topic in this chapter, and that topic is combination of solid figures. The next topic is combination of solid figures. So our focus will be on those solid figures which are made up of different solid figures. For example, I have told you previously the oil tanker, the tank fit at the back of a truck in which it used to carry oil or water. That tank is a solid which is a combination of different solid figures. For example, I told you that it looks something like this. So this is not any of the figure which matches to our standard solid figures. This figure is a combination of different solid figures, and how it is, because if I divide this cylinder, if I divide this figure into three parts, I can see the first part is a hemisphere, second part is a cylinder, and third part is again a hemisphere. So it means that there are such figures, there are such practical examples where we see different solid figures which are made up of combination of solids. So our main concern will be again only related to those standard figures that we have already studied in class 9th. Okay, that is the cylinder, the hollow cylinder, the cone, okay, the hemisphere, the sphere. So all these figures will come again, but they are joined to each other in some other way to form different solid figures. Okay, so let us understand this concept with the help of examples. We will going to solve 15th question from the practice sheet. The question number 15 in the practice sheet, it says a vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is 14 centimeter and the total height of the vessel is 13 centimeters. Find the inner surface area of the vessel. Okay, so let us try to understand the concept. It says a vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. So there is a vessel which looks like a hollow hemisphere, and at the top of that hollow hemisphere there is a cylinder. So if I try to draw the diagram for this question number 15, the diagram will be something like this. Okay, this is a hemisphere and the diameter of this hemisphere is given as 14 centimeters. Okay, and at the top of this hemisphere there is a cylinder like this. Okay, it's a hollow cylinder, it's an empty cylinder, nothing is inside the cylinder, because cylinder are of two types. One is hollow cylinder, another is a solid cylinder. Okay, solid cylinder, for example, a rod. Okay, a rod contains cylinder, it's completely full, there is nothing inside the rod, it's all the metals. Okay, it is all metal all around. So what is a hollow cylinder? Hollow cylinder is basically a pipe. You can see a pipe which carry water, it's an example of a hollow cylinder. So this vessel is something like this, that there is a hemisphere at the bottom and there is a cylinder at the top of this hemisphere. It is mounted on this hemisphere. So what we can observe in this figure is that the base of hemisphere and the base of cylinder are same. Okay, the base of hemisphere and the base of cylinder are same. So if the diameter of this hemisphere is 14 centimeter, I can say the diameter of this cylinder is also 14 centimeters. Okay, since the base of cylinder and hemisphere is same, it implies diameter of cylinder is equals to 14 centimeters. Okay, if diameter is 14, then what is the radius? Radius is 7 centimeters. The radius of hemisphere is also 7 centimeters. Okay, further it says the total height of the vessel is 13 centimeters. Now what is the total height? Total height means the length from top to bottom. Okay, the distance between the top and the bottom. Now top of the vessel is the top of the cylinder and the bottom of the vessel is the bottom of hemisphere. Okay, because bottom of cylinder is not the bottom of vessel. Vessel is made up of two different figures. That's why I will say that bottom of this hemisphere is the bottom of vessel. Okay, and it says this height is 13 centimeters. This complete height is 13 centimeters. Okay, now further I can see that since this is a hemisphere, then if I ask you what is the height of this hemisphere, if I ask you what is the height of the hemisphere, I can see that this hemisphere has the radius 7. So if the radius of hemisphere is 7, all the boundaries of this hemisphere are exactly 7 centimeters away from the center of the hemisphere. Okay, so it means this much length is also the radius, this is also radius, which is 7 centimeters. It means the height of the hemisphere is 7 centimeters. If height of the hemisphere is 7 centimeters, the height of this cylinder is, it is 13 minus 7, which is 6 centimeters. Okay, height of the cylinder is 6 centimeter and the height of this hemisphere or the radius of hemisphere is 7 centimeters. Now further it says find the inner surface area of the vessel. We need to determine the inner surface area of the vessel. Now what is inner surface? The inner surface of this vessel, inner surface is the surface inside this cylinder, okay, and the surface inside this hemisphere. This is the inner surface. Can I calculate the inner surface area, or if I talk about for in case of cylinder, I can see the inner surface is the area of boundary. Okay, area of boundary, area of walls is the inner surface of the cylinder. So in this case, inner surface of cylinder is basically what? Inner surface means the area of wall. And what is the area of wall in case of cylinder? We call the area of wall or the area of this vertical walls in this cylinder as curved surface area of cylinder. Okay, it is basically curved surface area of cylinder. Now what is curved surface area of cylinder? It is 2 pi RH. The formula for curved surface area of a cylinder is 2 pi RH. 2 and pi are constant. What is the radius? Radius is 7, and height of the cylinder, height just we have calculated, it is 6 centimeters. So the inner surface area or the curved surface area of cylinder is 2 pi, R is 7 into H is 6. So this will give you, it is 7 6 42, 42 into 2 is 84. So 84 pi centimeter square. This is the area of inner surface of this cylinder. Now what is the inner surface of hemisphere? Okay, inner surface of hemisphere. Inner surface of hemisphere means curved surface area of hemisphere. What is the curved surface area of hemisphere? It is, this is 2 pi r square. You know the formula for curved surface area of hemisphere. It is 2 pi r square. Radius of hemisphere is 7. So here I can write it is 2 pi into 7 square. So 7 square is 7 sevens are 49 and 49 into 2 is 98. So this is 98 pi centimeter square. Okay, this is the curved surface area of hemisphere. Okay, now try to analyze this. I haven't added up this area. Okay, the area of the base of the cylinder and the area of the top or the base of the hemisphere. You can see this area is hollow, there is nothing covered because this hollow cylinder and this hemisphere are joined from this base. So this area is not going to be calculated. We do not need to calculate the total surface area, we just need to calculate the curved surface area of two different figures. So here surface area of vessel is equals to curved surface area of cylinder plus curved surface area of hemisphere. These are the two things that we need to add up and you will get the surface area of this cylinder. Try to understand what is surface area. Surface area means the area on which you can paint. Okay, the area inside this vessel on which you can paint, you can color. So what you can see is you cannot color at the base, you cannot color here in middle of this. You can color the walls. Okay, you can color the walls, but you cannot color the joining portion. Okay, because this cylinder is hollow as well as this hemisphere is also hollow. There is nothing, a plate or any floor inside this. Okay, it's a hollow hemisphere and hollow cylinder. So the curved surface area of cylinder plus curved surface area of hemisphere is the total surface area of vessel. Surface area of vessel means the inner area on which I can paint, I can color. Okay, so this is the answer for question number 15. You just need to add this 98 pi and 84 pi and just solve using pi is equals to 22 upon 7 and you will get the final answer. Okay, so this is the solution for 15th question. You can see this question, it is a combination of solid figure because this vessel is made up of two different solid figures. Okay, so you can note this, then we will continue. Okay, let us now discuss question number 16 based on this concept. A toy is in the form of a cone of radius 3.5 centimeters mounted on a hemisphere of same radius. The total height of the toy is 15.5 centimeters. Find the total surface area of the toy. Okay, so it says that there is a toy which is in the form of a cone mounted on a hemisphere of same radius. So there is a hemisphere and on the top of that hemisphere I have mounted a cone to make this toy. So if we try to draw the diagram for this question, I can see, let us say this is the base, this is the hemisphere, okay, this is the base of toy, and at the top of this we have mounted a cone. Okay, this is a cone and this is the hemispherical base of this toy. The radius of this cone is given as 3.5 centimeters. So this is the radius and this is 3.5 centimeters. Further it says the total height of the toy is 15.5 centimeters. So height of the toy means the distance from the top of this cone to the bottom of this hemisphere. This is the height of the toy, which is 15.5 centimeters. Okay, this is the height of the toy. Now, what we can see is, since the height of the toy includes two things. First is a hemisphere at the bottom and a cone at the top of this hemisphere. So, if I talk about what is the height of this hemisphere, the radius of hemisphere and the cone are same because they have the same base. Okay, then this 3.5 centimeter is the radius of this base and this should be the radius of this hemisphere. That is, if I calculate the height of this hemisphere, the height of this hemisphere is again the radius of this hemisphere, that is 3.5. So it means that distance from base of the hemisphere to the bottom of this hemisphere is 3.5 centimeters. Okay. Now, if this distance is 3.5, what is the distance left above this? This much distance. This is 15.5 minus 3.5, that is 12 centimeters. So this length is 12 centimeters. So I will say that the height of the cone is basically 12 centimeters. Why this is 12 centimeter? Because this base hemisphere is of 3.5 centimeter radius. So this length is 3.5. So definitely from 15.5 total length, if I subtract this 3.5, I will get this, the height of cone, that is 12 centimeters. So the height of cone we have got 12 centimeters and our task is to calculate the total surface area of this toy. So to calculate the total surface area of this toy, what we need? What is the total surface area of this toy? The total surface area of toy means the area on which I can paint. Okay, the area on which I can paint, ऐसा area जिसके ऊपर मैं color कर सकता हूँ, that will be the total surface area. See, toy is like a hemisphere and a cone at the top. So if I try to color this toy, can I color the base of the cone or can I color the base of the hemisphere? No, I cannot color the base of the hemisphere and the base of the cone. So what portion of this toy I can color? I can color only the surface outside this cone and the surface outside this hemisphere. Okay. So what I mean to say is that total surface area of the toy includes the area of this cone excluding the base and area of this hemisphere excluding the base, because both the bases are joined to each other and the toy is formed. So I will say total surface area of toy is equals to, total surface area of toy is equals to curved surface area of cone plus curved surface area of hemisphere. Try to understand the concept, why I am including only the curved surface area of this hemisphere and curved surface area of this cone. It's because the toy is formed by joining the bases of these two figures. So these bases are joined. So if I want to calculate the surface area of the toy, these bases will not be included, because now the surface of the toy includes this surface, okay, this surface of cone and the south surface outside this hemisphere, okay, the outer surface of this cone and outer surface of this hemisphere, but not the base, because bases are joined. Okay, so I can color only this much part, that is the lateral surface area of this cone and lateral surface area of this hemisphere. I cannot color the base of hemisphere as well as the base of cone because they are joined. Okay, so what my task is to calculate the curved surface area of cone and curved surface area of hemisphere only. What is the curved surface area of cone? Curved surface area of cone is pi r l, and curved surface area of hemisphere is 2 pi r square. Okay. Now we know the radius. Do we know the length L? L is the slant height of cone. Slant height of cone means this height. This is the slant height. Now how to calculate the value of this slant height? I can see this is the vertical height of cone, this is the radius. So this triangle is a 90 degree, is a right angle triangle. This is 0 O, this is let us say A, and this is B. Triangle OAB is a right triangle. Therefore I can see L square is equals to 12 square plus 3.5 square. Okay, 3.5 means this one, and 12 is this height. Height square plus radius square is equals to L square. That is the Pythagoras theorem. So the value of L is square root of 144 plus this is 3.5, that is 3 4s are 12, 25. So 12.25 is the length. So I will get L is equals to square root of, this is 144, and when you add 12 it will become 156.25. This is the L. Okay, this is the value of L. So you can calculate this. It is square of 6.25. Okay, you can calculate this, or it is a cube of 25. That is, in our case it will be 2.5. So you need to calculate this. So we have value of L. Now we have value of radius. So what we will going to do is just substitute the value. So pi into radius is 3.5 into square root of 156.25 plus 2 times of pi into radius is 3.5 square. Okay. So this is the total surface area of this toy in centimeters square. Okay. So just try to understand the concept. Here the total surface area of toy is need to be calculated, but still I have calculated only the curved surface area of cone and curved surface area of hemisphere, and the reason is already I have told you. Reason, कोन और इस हेमिस्फीयर के बेस को हमने ज्वाइन कर दिया है, तो जब हम इस टॉय को कलर करना चाहेंगे, हम इसकी सरफेस को देखना चाहेंगे, तो उस सरफेस में ये जो बेस का एरिया है, जो बेस सरफेस है, ये इंक्लूड नहीं होगा, ये हमें दिखाई ही नहीं देगा. ओके, दैट्स व्हाई सिर्फ इसका कर्व सरफेस एरिया दिखाई देगा और इसका कर्व सरफेस एरिया दिखाई देगा. दैट्स व्हाई टोटल सरफेस एरिया इज CSA of cone plus CSA of hemisphere. So this is the solution for question number 16. Okay, let us move to question number 17. Question number 17 says a cubical block of side 7 centimeters is surmounted by a hemisphere. What is the greatest diameter the hemisphere can have? Find the surface area of solid. So it says that a cubical block of radius of side 7 centimeters, okay, the cubical block, the side of this cubical block is 7 centimeters, is mounted by a hemisphere, and a hemisphere is mounted at the top of this cubical block. What is the greatest diameter that hemisphere can have? Find the surface area of the solid. Okay, so how to solve this question? We need to draw a cubical block, and at the top of that cubical block there is a hemisphere. So first let us draw a cubical block. This is a cubical block, and at the top of this cubical block there is a hemisphere. It says what is the greatest diameter that hemisphere can have. See, if I just observe the top of this cubical block, which is of 7 centimeter in dimension, since it's a cubical block, so all the sides, the length, breadth and height of this block is 7, 7 and 7. If I just observe the top of this cubical block, I can see the top looks like this. This is the top of this cubical block. Now I need to put a hemisphere at this top of this cubical block, and it says what is the greatest diameter that the hemisphere can have. See, the base of the hemisphere is a circle. The base of this hemisphere is a circular base. So if I observe the hemisphere from the top, I can see that a hemisphere which is something like this, a hemisphere is like this, but if I observe it from the top, I can see only this. Okay, a hemisphere like this will look like this from when observed from the top. Okay, so since this cubical block I am observing it from the top, then this is the top of this cubical block, and on this cubical block, on this top, I am just surmounting this hemisphere. So we need to calculate the biggest diameter that this hemisphere can have. Now try to understand the concept. I am surmounting a hemisphere at the top of this cubical block, that is on this square. I am trying to surmount a circle at the square. Okay, I am trying to put a circle on this square. So we need to determine what is the biggest radius this circle can have when I substitute this circle on this square. See, I can put this circle like this also. Okay, I can have a small hemisphere and I can put this hemisphere at the top of this like this. Okay, it is possible. I can surmount this hemisphere at the top of this cube, or I can also enlarge this hemisphere and make it like this, that is like this. This is also a hemisphere which can be surmounted at the top of this cubical block. Further, it is asking that how much big the hemisphere can be, which can be surmounted at the top of this surface, top of this cubical block. So it can only be up to the dimension of this side. It can only be up to the dimension of this cubical block. The maximum dimension, maximum side, maximum length of this cubical block is 7 centimeters. Okay, 7 centimeters. So the size of the base of this hemisphere cannot be greater than 7 centimeters. It means the maximum size of this hemisphere can be like this. It can be a circle which is touching all the boundaries. Okay, it can be a circle which is touching all the boundaries of the square. It means the hemisphere can be like this. I can make the hemisphere like this, where I can see that all the points of the base of this hemisphere, that is all the points of the circle, are touching the circle. Now, can I have a hemisphere greater than this? Can I have the diameter of hemisphere, size of hemisphere greater than this? Let us try. If I make a hemisphere greater than this, what I can see is, I can observe that hemisphere is going out from this cubical block. Okay, hemisphere is cubical block के बाहर जा रहा है. But we need to surmount the hemisphere at the top of this cubical block. It means the hemisphere cannot be greater than the cubical block. Okay, hemisphere cubical block से बड़ा नहीं होना चाहिए. It can only be up to the size of cubical block. The maximum dimension this cubical block can have is 7 centimeters. So the length of this hemisphere, if I talk about the length of the base cannot be greater than length of this cubical block, which is 7 centimeter. So the radius of this radius of this hemisphere can only be maximum of 7 centimeters. Okay, why 7? Because if the radius of this this hemisphere is 7 centimeters, it will be like this blue one. Okay, this blue one represents the hemisphere which is having the greatest radius. Okay, so what I can write is the greatest radius greatest diameter of hemisphere should be such that it do not surpass the it should be such that it do not surpass the face of cubical block. Okay, it should not surpass the surface of cubical block. Okay, the top of cubical block or the face of cubical block. Okay, it cannot go outside the boundaries of this cubical block. That's why the maximum size of the hemisphere should match with the maximum size of this surface or this face of this cubical block. Okay, so at max this hemisphere can expand only up to 7 centimeters. That's why I can say the maximum dimension this hemisphere can have is 7 centimeters. So I will say the diameter, it implies the diameter of hemisphere is equals to 7 centimeter, which is maximum. Okay, at max it can have the diameter of 7 centimeters only. Okay, now so we have calculated the diameter of hemisphere. Now our next task is to find the total surface area or find the surface area of the solid. So try to analyze the solid. This is the solid. Okay, this is the hemisphere and this is the cube. This is the cubical block. Okay, this is the hemisphere and this is the cubical block. So this is our solid and I need to determine the surface area. Now, which part of this solid should be included in the surface area? I can see that this solid is made up of two different solid figures. One is hemisphere and another is a cubical block. So if I talk about the surface area of this solid, it means I want to calculate that on how much area I can paint. मैं कितने एरिया पे पेंट कर सकता हूं, कितने एरिया को कलर कर सकता हूं. That is the surface area of this solid. What I can see is all the faces of the cube are included in the surface area. क्यूब के सारे फेसेस हम सरफेस एरिया में इंक्लूड करते हैं. सेकेंड थिंग, हम इस हेमीस्फीयर का जो कर्व सरफेस एरिया है, ओके, इस हेमीस्फीयर का कर्व सरफेस एरिया, आसपास का एरिया, ये सरफेस एरिया भी इंक्लूड करते हैं इन दिस टोटल सरफेस एरिया ऑफ दिस सॉलिड में. ओके, बट ध्यान से देखिए, जब हमने इस हेमीस्फीयर को इस क्यूबिकल ब्लॉक के ऊपर रख दिया तो क्यूबिकल ब्लॉक का कितना पोर्शन हाइड हो गया, क्यूबिकल ब्लॉक की सरफेस का कितना पोर्शन हाइड हो गया. आई कैन सी दैट द बेस ऑफ दिस hemisphere shows the area of this cubical block that is hidden. Okay, जितना एरिया इस हेमिस्फीयर के बेस का है उतना ही एरिया इस क्यूबिकल ब्लॉक का हाइड हो गया. Why? Because हमने उस एरिया पे ये हेमिस्फीयर रख दिया. Okay, उस एरिया पे क्यूबिकल ब्लॉक को छुपा के हेमिस्फीयर रख दिया. So what I can say is that surface area of cubical block that hides due to hemisphere is equal to surface area of base of हेमीस्फीयर. ओके, बिकॉज अगर ये हेमीस्फीयर नहीं होता तो मैं इस क्यूबिकल ब्लॉक के हर सरफेस पे पेंट कर सकता था, इस टॉप सरफेस पे भी पेंट कर सकता था. लेकिन जैसे ही हमने इसके ऊपर हेमीस्फीयर रखा, हम ये देखते हैं कि हेमीस्फीयर का जो बेस है और जो इस क्यूबिकल ब्लॉक का जो टॉप है, इन दोनों के बीच में जैसे ही हमने इनको एक साथ चिपकाया, एक साथ जोड़ा, वैसे ही इतना एरिया, इतना बीच का एरिया हाइड हो गया. और ये एरिया किसके बराबर है? जितना इस हेमिस्फीयर का बेस है उतना ही एरिया इस क्यूबिकल ब्लॉक का हाइड हो गया. ओके, सो अगर मैं इस सॉलिड का सरफेस एरिया निकालना चाहता हूं, सो व्हाट आई कैन सी इज, सिंस दिस सॉलिड इज मेड अप ऑफ two different parts, one is hemisphere, another is cubical block, what I can do is I can calculate the surface area of this cubical block. I can calculate the curved surface area of this hemisphere. Why curved surface area? It's because base area को हम include नहीं कर सकते, base area तो छुप गया है. Okay, hence surface area of solid is equals to surface area of cube plus surface area of hemisphere minus, now why minus? बिकॉज हमने सरफेस एरिया ऑफ क्यूब पूरा ले लिया, हमने इस हेमिस्फीयर के टॉप सरफेस का एरिया ले लिया, लेकिन उतना एरिया जो कि इस हेमिस्फीयर के बेस से छुपा है उतना एरिया हमें माइनस करना है, बिकॉज वो एरिया को हम इंक्लूड नहीं कर सकते. सो अगर मुझे एरिया माइनस करना है, सो आई नीड टू सब्ट्रैक्ट दिस मच एरिया, आई नीड टू सब्ट्रैक्ट दिस मच एरिया. विच एरिया इज दिस? This is the area of the base of this hemisphere. Okay, because इस cubical block के surface, इस cubical block के top पे जो इतना एरिया है, जो corners में एरिया बच रहा है, वह तो हमें इंक्लूड करना ही है. ओके, मुझे ये वाला एरिया तो इंक्लूड करना है, इतना एरिया इस कोने से, लाइक दिस. ये 4 parts, but I do not want to include this area, I want to exclude this area. So definitely ये एरिया एक्सक्लूड करने के लिए हम क्या कर सकते हैं, हम इस क्यूब का सरफेस एरिया निकालते हैं और उसमें से इतना एरिया जितना इस हेमिस्फीयर का बेस है उतना एरिया इसमें से माइनस कर देते हैं. सो जो एरिया बचेगा दैट विल बी द सरफेस एरिया ऑफ क्यूबिकल ब्लॉक दैट इज लेफ्ट ऑन दिस सॉलिड. एंड सिंस इस एरिया पे हमने क्या रख दिया है, इस एरिया पे हमने इस हेमिस्फीयर को रख दिया, तो इसीलिए हम इंक्लूड क्या करेंगे, हम हेमिस्फीयर के इस कर्व सरफेस एरिया को इंक्लूड करेंगे. ओके, ट्राई टू विजुअलाइज द टोटल सरफेस एरिया एज द एरिया ऑन विच आई कैन पेंट, जिस एरिया पे मैं कलर कर सकता हूं, क्या आप इस सरफेस, इस हेमिस्फीयर और इस क्यूबिकल ब्लॉक के जॉइनिंग पे, इन दोनों के बेस पे कलर कर सकते हैं? नहीं, बिकॉज ये तो छुप गएगा। ओके, ये छुप जाएगा, बचेगा क्या? सिर्फ हेमिस्फीयर का कर्व सरफेस एरिया, इस क्यूबिकल ब्लॉक के 5 फेसेस का एरिया और इस वाले फेस पर सिर्फ कॉर्नर्स का एरिया। ये 4 कॉर्नर्स का एरिया बचेगा। अगर टॉप से देखें तो ये ऐसा दिखेगा, साइड से देखें तो ये ऐसा दिखेगा। ओके, सो दैट्स व्हाई कर्व सरफेस एरिया ऑफ क्यूब प्लस कर्व सरफेस एरिया ऑफ हेमिस्फीयर माइनस बेस एरिया ऑफ हेमिस्फीयर, हम इसमें से हेमिस्फीयर के बेस का एरिया सब्ट्रैक्ट कर देंगे। नाउ let us calculate the value of this. Let us solve this. Now surface area of cube. What is the surface area of cube? This is 7. Side of the cube is 7 and we know the formula for surface area of cube. It is 6a square. So it is 6 times 7 square plus surface area of hemisphere. Now what is the surface area of hemisphere? Remember, surface area of hemisphere means curved surface area because base का area हम include नहीं कर रहे. So curved surface area is 2 pi r square. So 2 pi. Now what is radius of this hemisphere? We have just calculated that diameter is 7. So radius r is equals to 7 by 2. That is 3.5. So here I can write 7 by 2 square. Now minus area of base of this hemisphere. Area of base is pi r square. So minus pi into r is 7 by 2 and square. So this will give you 6 into 49 plus 2 pi r square minus pi r square means plus pi into 7 by 2 square in centimeters square. So this should be the surface area of this solid, which is a combination of hemisphere and a cube. Okay, try to analyze this. Why I have subtracted this much area? Because इस एरिया पे मैं पेंट नहीं कर सकता, मैं सिर्फ इसके सरफेस पे ऊपर पेंट कर सकता हूं और इस क्यूब पे पेंट कर सकता हूं, इंक्लूडिंग दिस कॉर्नर पार्ट्स, बट एक्सक्लूडिंग दिस एरिया which is covered by the hemisphere. Okay, so this question is a very interesting question, very logical question. You need to subtract this area. This is the most important part. Okay, so this is the solution for 17th question. Okay, so you can note this, then we will continue.